Alright folks, a new item on the bench. Once again, another one of those HANTAREX 900E monitor chassis, arcade monitor chassis. This is number 3 of, 5 or 6 that I have for repair. I got them over the years and never gave them much attention. And they're very, very nice chassis, as in they create a very, very nice picture. The color circuit is actually quite full. There's a lot going on, but it makes for a very nice picture. Unfortunately, it also means they can be tricky to diagnose and fix sometimes. But luckily, in these, there's usually a handful of things that can go wrong, typically. Beyond that, yeah, it takes a little bit more of figuring out.
What now? This video is sponsored by PC.
No. We don't do that here.
They make the PCB. Okay. They offer PCB manufacturing and part assembly, of course, but they also offer a number of other services like CNC machining, metal sheet fabrication, 3D printing, and even injection molding. Pretty much anything you need for all your projects. Go to PCBWay.com, upload your project files, and get an instant quote.
And thank you to them for sponsoring this video.
Thank you, PCBWay.
So this one was sold to me as non-working, and I'm giving it a visual inspection. Right away, I can see that this socket will need to be changed. I don't have any monitor for these, and this it needs one of those sockets instead, with holes instead of just sliding pins, which I never like. They are compatible, they're pin compatible. They do the same stuff, except you won't be able to fit a tube for that into this. So it's just slightly different. So I've actually quite a few of these that I can fit for those. So it's handy. I'm going to do that. It's probably going to be the first. It will most likely need a recap. Yeah, a lot of these caps are somewhat crusty looking and worn. There's a lot of caps on these. I haven't counted, but there's let's count for the sake of knowing 1, 2, 3, 4, 31, 32, 33 caps on this, making recapping it a potentially painful experience. Actually, let's do a quick, just a very quick walkthrough of this. So here we got our mains coming through here. We got some stuff for degas and all that. They're not needed, those connections, really, just to test at least. We got our high power here with our bridge rectifier, like 4 diodes. B plus ends up being set here at this spot. And then our currents, our B plus goes from here into our high voltage section here. This section here, all here, this entire strip is dedicated to colors. So we got whatever light and contrast, or whichever way, which is which. And all this is just red, blue, and green. Actually, we get red, blue, and green right there, those 3 wires. And again, we get sync coming right here. So there's like 4 amplifier circuits in here, and you can see the same circuit is repeated 3 times for each color, and the sync circuit is fitted here somewhere. We got plus 12 and minus 5 going from here into the main board, the yoke board. That's fair enough. And all here is this area sort of dedicated to our vertical IC, so our vertical section. We got our horizontal IC right there, and horizontal section somewhere there. We get our width cap here and our width coil, our linearity coil here. And that's roughly what's going on. When I say width cap, all those caps sort of affect the width, but this is the main width cap, and obviously flyback and all that. So with this, they're great chassis, like I said, for colors, really nice crisp picture. There's a handful of things that typically go wrong with these. The first one is this TH2. This transistor often fails and breaks. So there's 2 little coils going on in there. So there's a big coil here, which we can see, but under that, there's a very thin wire, and that wire often breaks here. It gets corroded and breaks. in those chassis only. I haven't seen that happen in other chassis, but it's typical of the 900E. So I wonder, when they were made, was there a bad batch of these guys that was fitted in all? Because you find these in a lot of other HANTAREX chassis, but they don't get as damaged, or they don't break. They're usually fine. Meaning you can actually salvage stuff from other chassis, which is probably, if this is broken, this is what we'll have to do. Other than that, we get a lot of heat generated on these transistors, like a ton of heat, and there's no heat sinks on them, which may be an oversight of the design, but that means very often we either get burnt, here some traces of burn, or simple cold solder joints that happen. So yeah, I see the legs moving. I don't know if you can see it here. There you go. Can you actually see the legs moving here? Anyway, it doesn't matter. So a lot of these need to be reflowed very often. And what else? Yeah, the caps on these, if they're old enough, need to be changed. So we'll at least change all those big caps. This one definitely, and this guy, and these guys, the big ones. I'm not leaving those crusty cap on before I power this this chassis. The other thing that can happen is this guy heats up tremendously and can sometimes burn holes right here. It's not the case here. In fact, I'd say this chassis is in pretty good condition underneath. Very often you get cold solder as well on the underneath, but I see no visible trace of heat damage. A little bit of crusting here, but it's actually nice. But so I'll inspect all that for cold solder as well, and then yeah, we'll see. So first step is I'm gonna need to change this guy. We're gonna check if this is broken by simply, you can actually just measure for continuity between here and here and here and here, and very often between here and here is broken. Oh yeah, quick word about the B+. So B+ can be set at this pot right here, but the way you measure it is through this red wire here. So you just get, so in circuit, while it is powered, you can get a measurement from here. So you just connect your ground to the chassis frame, and then you measure B+ here, or at this connection here. Another way you can measure B+, but typically if you have the monitor plugged in and connected to a tube, you need this, and the reason is this won't work. So pin, let me get, the other way you can measure B+ is a pin tree here, right here, this guy, and it's because B+ comes here and it needs to be sent to pin 4. So when you connect the yoke plug, it actually bridges pin 3 and 4, and then the monitor starts. If you don't have anything plugged in here, the monitor will not start. But you can still get B+, as in the high voltage section won't start. You can still get B+ from here. With this, with that disconnected, it's just B+ won't be going over to pin 4 and bring B+ to this section. So you can measure it from pin 3, but it's much easier to measure it from this red wire here, or here, and get a reading. You need 115 volts for B+. The other thing is this chassis will take I think from 98 to 130 volts to start. So, and then obviously the voltage will need to be converted to 115. It's easier to have, like, usually 128 is the recommended voltage. On my test rig I have 125, and it's plenty. 100 volt will also start it. I've tested it with that. You might actually get a narrow picture. As B+ is increased, the picture, you'll see the picture widens, or If you decrease B+, the picture will get smaller and smaller. I've had the issue where B+ couldn't reach above 90 volts, and I had essentially a very, very narrow picture, like almost square. Voltage-wise, like I said, you need 12 volt and 5 volt here going to the neck board, and there's a third voltage that goes from, I think it's this blue wire right here, and it arrives here. All right, it arrives here, and that's 200 volts. That's also needed to get any sort of picture. So if you're missing, I've noticed if you're missing either 5 volt or that 200 volt line, you'll get essentially just a white screen with retrace lines on it. But that's all you'll get. You'll just get that white screen. So if you get that, it's usually a good indication that either that -5 or more likely that that plus 200 volts is missing. -5 is derived from this power regulator, and that gets usually around, I think, -8 volts coming from this IC. Vertical IC through a few hoops, but you can measure it here at this side or this side of this this resistor. I think it's -8 point something. So first I want to check that this guy is good. Here we should have continuity. If I can, oh no, you know, it'll be easier on this side. Okay, so first I want to check that we have continuity here on this one side. That's the big coil, and nothing here. Well, there you go. This guy at least is bad. TH2, unsurprisingly. So this guy is bad, and I think every single one of these I've had for repair was bad. Now the cool thing, have I got, yes, I do have one here. Right, so this is a different chassis, but I just wanted to show you this. This is a HANTAREX Polo 3 type of chassis. Great chassis, they're often used for poker machines, typically the Norwood poker machines would have had them in them. But the cool thing about these chassis is they share a lot of parts, cab values and yeah, different ICs are similar to the 900E from HANTAREX as well, including this little transformer here. So we can actually take that from this chassis if it works and put that into our other chassis, which is what I did on the previous repairs that you've seen already. So we'll desolder that and put that on the other one. All right, that's our guy. I suppose we should test it. I haven't done that. So big side, yeah, working. Small side working, great. And I think I've never seen a bad one of these on those chassis. All right, so power goes in here. The two wires on the left hand side. There's space for 2 wires here, and that's actually for 220 volts for the degauss circuit, but we're not using that. We need our RGB connection going in here, and we need our yoke connector here, and this way. And the flicker is due to this light not working properly, not from because of anything bad I've done. So right now I don't need any of this. I'm going to put that away. We'll measure voltages later on. I'm going to power the Pandora box. And I'm going to power this. 1, 2, 3. And that's not a good sound. I don't hear anything. I don't think we're getting any picture. We're not getting high voltage at all to this board, I'm gonna guess. Right. All right, so a couple of measurements I can do is actually test our B plus here. So unloaded, it's probably gonna, yeah, that's okay for now. We'll have to bring it down. When 160 unloaded without anything working is fine. How about our plus 12? Plus 12 is 3 volts. That's not good. That's not good at all. How about our plus 5, which is over here? Minus 5, sorry. We're reading 2 volts as well. And are we getting anything on this side of this resistor over there? It should read minus something coming from. No, so we're not getting our voltage to our voltage regulator, this guy. We're not getting anything to this guy. So it could very well be. I'm going to do testing along in that circuit. There's a couple of diodes on the way as well, but I'm banking on this guy, this IC being bad. So let's bring this back to the workbench and do a little bit more testing, and we'll see. But I'm suspecting this IC to be bad. The thing won't even start if the voltages aren't even present here. All right, I've got the chassis back on the bench, and I've taken out the horizontal IC, come on, focus thing. And I don't know if you can see, probably not, because it's just having a hard time focusing, this new camera. Anyway, it's a single swipe socket, and these typically, when you see them, replace them. Don't even bother. And I've done that actually with the other chassis, but I forgot here. And you can see there's some traces. Can you get the focus? Come on, please. You can see some traces of corrosion on the pins. It might be the source of our issue. It might be a compounded issue. It might have nothing to do with the issue, but I'm still going to change that socket to rule it out and put in a new IC. I have a few working ICs. It's 2513, I think that's what they are. I have a few of them, and see if that fixes our problem. All right, we got our new IC in. And a new socket in. I actually did some testing after that, and it still wasn't working. The chassis just wasn't starting. Essentially, we just weren't getting power to the flyback. I could test that B plus. There's a B plus point right behind the flyback there, and B plus was going around properly as it should around the board, but we weren't getting any sort of initialization of the flyback. There's a cool test you can do with one of these neon bulbs and actually bring that, yeah, and you can see it light up like that. It's pretty cool, but it's a good indication that we have the flyback is getting current in the primary, and that wasn't the case. So usually it's because, as we saw, this guy was bad, but this is what essentially drives the HOT. And I tested the HOT, and the HOT tested fine. It's that big IC that you see right. The HOT is this big guy right here. And so that tested fine. So after that, the HOT was tested fine. I just double checked that this was continuity here, and it was. And then I checked the voltages, and there was nothing coming in this transformer. So I started looking before, and before we have what's called the horizontal drive transformer, not the horizontal output transformer transistor, but the horizontal drive transistor, and it's this little guy at the tip of my finger, and indeed it tested bad, and so I replaced that, and we have, you can actually see there's a picture behind there somewhere, but I think we're getting quite probably a collar is driven too high, but we finally get high voltage to the flyback. So let's continue. We're not out of the woods yet. All right, back from the bench, and I ended up just looking at the neck board. I think what I said on the previous segment was that it could be in this section, in the collar section. And then I just thought, of course, it's most likely not. One way you can tell is by just measuring the voltages. You see those wires here? There's a blue, green, and red, and you can just measure the voltages right there. It should be around 1.5, 1.8, which was fine. So that told me that the issue was probably more in the neck socket section. And indeed, the next thing you can do there is actually remove those guys and see if the error disappears, and it did. I was getting a picture just without the blue, so I tested those, and it turned out that this guy had gone bad. So I replaced it, and let's just start this guy. It takes a minute, but we've got a picture. We got quite a clear picture, but the colors are a little bit tired. There's a little bit of jitter, and it's because I haven't connected the ground on the socket, on the neck socket board. But yeah, I think I just tested, and the way I got this picture was essentially by cranking the blue all the way up. So I think we're okay here, but I think because I haven't replaced any of the caps in the collar section, all the collar lines, it looks like we've some old caps here. They're very crusty looking. Yeah, we got some old tired caps in this section. All right, so I've done a recap on this guy, and yeah, we do get a lot crispier collars, much stronger. I think though, it's very windy outside. I think though we have a very tired flyback, because if I play with the focus pot, it just, look at that, it's gone very blurry. If I just push the focus pot, yeah, it comes back. So I think we have, and it's at max, and it kind of dips in and out of focus. I think we have a dodgy pot on the flyback anyway. So I think what we have here is a flyback that's slowly on its way out. It probably will last for a while, but the focus being, you know, max and just barely getting focus after checking every cap in that circuit as well, and recapping, and the fact that the pot is wobbly. If I push it a little, it gets out of focus. So I think we have an old flyback. Now I have here 3 more of these. There's a flyback here because I did a swap on a previous chassis ages ago, and I thought the flyback was bad. Turns out this was good. But I have essentially 3 flyback, and this one is my donor chassis for repairing the rest of them. So we'll probably be able to repair those, and this is going to be our donor chassis. But I want to go through these first and see if there's, you know, any of them has a dead flyback. I'll use this one for that, and you know, that maybe in time. If not, I can transplant the flyback to this guy and at least get a better picture. So we can consider this flyback as fixed. Well, I mean, definitely fixed. It wasn't starting. We had a bad TH2, a bad driver transistor, horizontal driver transistor. We had a bad transistor here that was overdriving the blue beam, and I think that was all. Full recap, and a new socket on the horizontal IC, which was fine. The IC itself is fine. But there you go. I think that was all. Another cool repair, another monitor brought back to life. Delighted with the image and the colors on this one. Oh, and by the way, I fixed my tube degauss thing. Use one of those. Anyway, folks, another monitor repair on this channel. I hope you enjoy these. Third one. I have two more to do, at least two more to do, of this type of chassis. I want to do a lot more monitor repairs this year, so I've no shortage of chassis to repair anyway, so it's perfect. Anyway, folks, thank you for watching. Don't forget you can find me on Instagram and Twitter and all those places. Banjo Guy Ollie is the name. And there's a Discord server if you want to chat about all sort of things. I'll put the links in the description. Thank you for watching, and I'll see you next time.